Hi students, in this video we're going to look at how to apply our knowledge of trigonometry to solve problems involving bearings. Right, so after watching this video you should be able to define true bearings, state the true bearing of an object and its opposite direction, and then apply trigonometry to solve problems involving bearings. Right, so things to recall, as always, our right angle triangle and labeling the sides, hypotenuse, adjacent and opposite, recalling our trig ratios and their rules, sine, cos and tan, and also being able to calculate unknown sides and unknown angles of right angle triangles. Alright, so bearings are used to describe the direction of one object from another. So you might have talked about directions like north, northeast, southwest, west, whatever it might be. Those help us describe direction in words. But what if it's not exactly northeast? Or what if it's not exactly southwest? Well, we need to use our angles to help us describe exactly what direction we're going in. Now, true bearings are one way of describing directions. So true bearings take north as 0, 0, 0 degrees true, and then the bearing is measured clockwise. So a few things with bearings: always has 3 digits. Okay, always has 3 digits, so 0, 0, 0 is taken as north. For northeast would be 045 degrees. So always 3 digits, and there's always degrees true at the end. So that T tells us that we're using a true bearing, and that helps us work out what unit we're using in terms of working out our bearings. So let's look at an example. We want to sketch the bearing 240 degrees true. Well, north will be 0, 0, 0 degrees true. Going around to east, that'll be 90 degrees true. And just 90 degrees round to east, another 90 degrees to south. So that's 180 true. West will be another 90 degrees, 270, and then with 360, we get back to north. Okay, so 360 full revolution. Now 240, well, that means we're getting to 180 degrees and then going an extra 60 degrees there. And that bearing there should give us 240 degrees true. And that's how we can locate bearings on our compass diagram. All right. So let's do some other examples. Determine the bearings of the points A, B, and C in the diagram below from the origin O. There's another part there, determine the bearing of O from C, so going in reverse. But let's do them in order. So first of all, the bearing of point A. So remember, north is 0, 0, 0 degrees true, and then we measure clockwise. So we know this angle from A down to east is 50 degrees. So our angle up here will be 90, subtract 50 degrees, 40 degrees. So for A, our bearing is 40, 040 degrees true. Around from there. All right, for B, we're going from north all the way around to where B is there. South is 180 degrees, and then we got an extra 75. So our bearing will be 180 degrees from north to south, and then we're adding on that extra 75, sorry. So that'll be 255 degrees. So for B, our bearing is 255 degrees true. Finally, for C, we're going to go all the way around to see here. At west, that's 270 degrees true. Then we're adding on an extra 20. So 270 degrees plus our extra 20 gives us 290 degrees. So our bearing C is 290 degrees true. Now, the question is, what about if we're going backwards? What if we're going from C in this last one? What if we're going from C back to O? Now imagine if this was in real life. You're walking in one direction from place A to place B. You get to place B. What would you have to do to get back to where you started from? Well, you just turn around 180 degrees and spin, turn yourself around and start walking. You're turning around 180 degrees. So what we're going to do then, say from C to O, right? Well, our bearing of C from O is 290, so we're going back 180. That'll be 290 subtract 180, so that'll be 110 degrees true to head back in the opposite direction. So walking one way from O to C, to get back we'll spin around 180. So we'll subtract 180 or add 180, depending on what number you're using. In this case, it makes sense to subtract 180 because that gives us a number smaller than 360 going back in the opposite direction. So subtracting 180 gives us 110 degrees true, and we'll walk that direction back. All right, so in this second example, we've got a boat that sails 4 k's south, and then a further 8 k's at a bearing of 140 degrees true. So let's just draw a quick diagram to see what we're looking at here. So let's say we've got our boat here, and then from that point, from our boat, we're going to draw some axes. So there's our axes, there's north, east, south, west. And then we're told we travel 8 k's south, 4 k's south. So in our diagram, starting from our boat, we'll go 4 k's south. Then we'll just say we finish here. And then once again, from that point, let's draw a new axis. And from there, north, east, south, west. From that point, we're told we travel 8 kilometers at a bearing of 140. So 90 is over here at east, so 140 will be somewhere down here, and our angle is 50 degrees more than the 90 degrees going to east. That gives us 140. Now, how far east has the boat traveled? Well, that will be this length here. Okay, so that will be our answer to A, how far east he's traveled. And then how far south? Well, from where we started, we've traveled a good way south, that 4 k's south to there, plus the extra bit on top in here. So for B, our distance south will be the 4 k's here, plus whatever that extra blue distance is that we've gone south in that second part of the leg. So, starting off with part A, we can do some trigonometry. We've got our angle, and let's label our sides. We've got our hypotenuse, opposite, and our adjacent. So this green side, how far we've gone east, that's our A value. And this hypotenuse length, we actually know as well. That hypotenuse length is 8 kilometers. We were told that in the question. So for A, to find out how far east we've got sides A and H. A and H is means we need to use cos. So cos of our angle equals adjacent over hypotenuse. Our angle, as we worked out, is 50 degrees. And that's, let's just call it A over 8, rearranging that by timesing both sides by 8. 8 cos 50 equals A. So A is going to be 5.14 kilometers. So on this boat trip, they've traveled 5.14 k's east in this direction from where they've started. Now for the south part, okay, our distance, we know the start of our journey, we've traveled 4 k's south, so we just need to work out this bottom part. So again, using our triangle, this blue side here is the same as the blue side here on our right angle triangle, which is our opposite side. Opposite side on hypotenuse is a sure sign for using sine. So the sine of our angle equals opposite over hypotenuse. Let's just keep it as O. Sine 50 equals O over 8. 8 sine 50 equals our opposite side. So our opposite side ends up equaling 6.13 kilometers. So the total distance we've gone south will be the 6.13 we've travelled south in this second leg, plus the extra 4 from that first part of the journey. So our total distance equals 6.13 plus 4 k's is 10.13 kilometers south, is how far we've travelled in total. Right, so after watching this video, you should be able to define true bearings, state a true bearing and its opposite direction by adding or subtracting 180, doing your turnaround, and then apply an understanding of trigonometry to solve problems involving bearings.